Good morning to all. My name is R. Joseph Paul, Assistant Professor, Department of Mathematics, SNS College of Engineering, Coimbatore. Today, we are going to discuss about a graph theory and a degree of a vertices. So, in the previous classes, we were discussing about what is graph theory, what is simple graph and multiple graph, finite and infinite graphs, adjacency and the incidence of graphs. So all these have some relationship on a degree of vertices. To have a degree of vertices, we must have some edges must be incident with the vertices, or the two vertices must be adjacent with some vertices. So already we have discussed that if E is an edge is adjacent with U and V, then the end point U and V are incident with E. So when we talk about a degree of vertices, the graph must be a finite graph. So for those graphs, we can define a degree of a vertices. So the degree of a vertices plays a vital role in a graph theory, which it means the number of edges which is incident with V, it's called as a degree. So previously when we are talking about direct and undirected graph, so already I said when we'll say G is a graph, it's a undirected graph. It's a simple undirected graph. It's always denoted as G. So when we talk about a direct and undirected graph, we are talking about undirected graph, which it means a number of edges incident on the vertex V. It's called as a degree of vertices of that point. So when we come to the direct graph, the number of vertices, that is in vertices we'll say. So its meaning is it's receiving the signal. That is a meaning. It's called as a degree, and out degree it's called as it goes out from the vertices of a graph. So here now we discuss about what is the degree of a vertex. So look at this. A degree of a vertex V in a graph G denoted by degree of V. It's simple notation DEG of V or dV. Its meaning is we are going to calculate a degree of the vertex. Is the number of edges incident to V in G. Its meaning is number of edges is incident to V in G with each loops and V counted twice. For a loop graph, we'll say the starting and the ending point of the edges are same. So we'll calculate twice the edges for loop. Since the degree of the vertices counts its incident edges, it is obvious that the sum of the degree of all the vertices in a graph G is related to the total number of edges. So look at here, the sum of the degree of all the vertices in the graph G is related to total number of the edges in the graph G. So when we look the example 1, the vertex V1 have 1 degree. So here 3, 3, 2, 5, 2, 0. 0, it's an pendant vertex, that is isolated vertices. It have no edges. So its degree is going to be 0. So we have a loop, it is counted twice and the remaining 3 edges are instant with it. So we are saying its degree is going to be 5. So this is the proof which was proved that the sum of the degree is equal to twice the number of edges. So we are defining a graph G is equal to V comma E be a graph with M edges we have. Then the sum of the degree of the vertices is equal to twice the edges. So every non-loop edges is incident to exactly 2 distant vertices of a graph G. On the other hand, every loop edges is counted twice in the degree of its instant vertices in G. Thus, we are saying that every edges, either it is loops or not, it contributes a 2 to the sum of the degree of the vertices of graph G. So it states that every degree it's equal to twice the number of edges. So thank you. So we'll discuss about some nature of graphs in the next class. Thank you.